Question 25. Find the angles between pair of lines. So we are given two symmetric equations, and from there we can find angle between the lines. I'd like you to do the question and then look into my solution, right? To find angles between the lines, we are concerned with their direction, right? Vector direction, right? So direction vector of these lines is 3, 5, 4 and 1, 1, 2, correct? And as you remember, A dot B, the two vectors, if you have to find angle between them, then if the two vectors are, in this case, M1 and M2, then M1 dot M2 is equals to magnitude of M1 times magnitude of M2, correct? Times cos of theta, right? So cos theta will give us the angle. So from here we can say cos of theta is equals to M1 dot M2, right, divided by the magnitudes of M1 and M2, and theta equals to cos inverse of this, correct, M1 dot M2 divided by magnitude of their vector directions, right, direction vectors. Okay, so that is what we need to do. Now here we will plug in the values and I will leave the calculations for you to do, right? So how we are going to do it is like this. So angle theta is equals to cos inverse of, what is M1? M1 is 3, 5, 4. So we get this 3, 5, 4, this vector M1 dot the vector 1, 1, 2, correct, over the magnitudes, right? So the magnitudes are square root of 3 square plus 5 square plus 4 square, right? 3 square plus, I should have written 5 here, but okay, times magnitude of 1 square plus 1 square plus 2 square, correct? So that's their magnitude, right? So you do this calculation and then find cos inverse of the value and get your answer. So we have cos inverse of 3 times 1 is 3, plus 5 times 1 is 5, 4 times 2 is 8, right? And in the denominator we have 9 plus 16 plus 25, right? So 9 plus 16 plus 25. So 9 plus 16 is 25, and 25 times plus 25 is 50. So we get 50 here times square root of 1 plus 1 plus 4, that means 6, right? So that is it, and we have cos inverse of 8 plus 8, 16, right? And this could be written as 2 square root 5, 25. So, sorry, 25 times 2, which is 5 square root 2 times square root 6, right? So anyway, so this is what you get, and which is 12, and 4 times 3 is 12. We can still simplify this, correct? Cos inverse of, here we have 16 and denominator 2, this is 2 times 3 is 6, right? So 2 will come out, right? So we get 10 square root of 3. Use calculator and find your answer, correct? So that's how you get angle theta between the two lines. Remember one thing, that when you're doing these lines thing, so let me remind you one thing, that let me make a rough sketch here, correct? Now one of the lines is 3, 5, 4. 3, 5, 4 means 3 along the x-axis, so 1, 2, 3, and then 5 along y, so we say 1, 2, 3, 4, 5, and then 4 up, so we say 1, 2, 3, 4. So it lands here. So from here, this is my line, and this line is kind of like going like this, right? That's my line, correct? The other line for us is 1, 1, and 2. That means you go 1 here, and then 1 here, and then 1, 2. Let's say this one, right? So the other line is kind of going like this through the origin. Is it okay? So one of the angles is always the acute angle, correct? So here we can say this angle, acute angle, correct? And the other angle is These are the two angles, right? So one is this angle, the other one is 180 minus that angle. Find the angles between pair of lines. That means we can say, well, our angles are one acute angle, the other obtuse angle, which is 180 minus that acute angle, okay? So remember that. Let's assume this is theta, the other one is 180 minus theta, correct? So you should mention both if you see here angles, right? That's the key issue, okay? So in the next question, we have mentioned very clearly, find acute angles. Let's move on to question 26.